When building complex mobile games, as developers, we need to pay close attention to their performance on our players' devices. Performance issues can affect gameplay, drain more battery, and can make a game unplayable, or leave our users' devices hot, providing them with an uncomfortable experience. An excessive amount of heat generated by our mobile devices will also cause thermal throttling. So, why does thermal throttling affect our mobile game's performance? Well, as your game attempts to do more work, such as rendering or processing game logic, our CPUs and GPUs use more power. More power means more heat produced, and our mobile devices will slow down device performance in an attempt to reduce its temperature and ensure that the device isn't damaged. With Unity's adaptive performance, we can monitor the device's thermal and power state and be able to react appropriately. For example, when playing over an extended period of time, we can reduce our level of detail or LOD bias dynamically to ensure that our game runs smoothly over an extended period of time. Adaptive performance allows developers to increase performance in a controlled way, which minimizes disruption to player experience. In this video, we'll be showing you some of the features of adaptive performance and how we can simulate scenarios in the editor. To learn more about specific details of adaptive performance, please see the documentation linked in the description below. Installing adaptive performance. To get started, we'll need to download the Adaptive Performance package from the Package Manager, which can be found in Window, Package Manager. Ensure that the Unity registry is selected in the top left corner and find the Adaptive Performance package. Click the Install button to import Adaptive Performance to your project. You can also install Adaptive Performance directly by going to Edit, Project Settings, Adaptive Performance, and clicking Install Adaptive Performance. Adaptive Performance will only work with data provider subsystems. To install Adaptive Performance for Samsung, head to Edit, Project Settings, Adaptive Performance. Select the Android tab and click Samsung Android Provider. This will import the Samsung Data Provider subsystems into your project. We'll also need to install the Device Simulator package. Using Adaptive Performance. By default, Adaptive Performance starts when your game boots up. This feature can be disabled in Edit, Project Settings, Adaptive Performance. You can uncheck the toggle box Initialize Adaptive Performance on Startup based on the target platform you intend to release to. How does Adaptive Performance work? Adaptive Performance determines which game settings to tweak based on key metrics, including: did your game reach the desired frame rate based on previous frames? Is the device's temperature rising? Is the device close to thermal throttling? Or is the device CPU or GPU bound? Depending on the state of the device based on these 4 metrics, Adaptive Performance will tweak adjusted settings to reduce the bottleneck. This is done by providing an integer value that describes the state of a device known as an indexer. Indexers and scalars. An indexer is a system which keeps track of your device's thermal and performance state and provides a quantified quality index. Scalars represent individual features in your game which can include but are not limited to graphics settings and physics settings. Scalars adjust themselves based on the indexer's value. We can view which scalars are available in Device Simulator's Adaptive Performance extensions. To switch to Device Simulator view, click the Game dropdown in the top left corner of the Game view and switch it to the Simulator view. Towards the left side of the Simulator tab, you'll see extensions called Adaptive Performance and Adaptive Performance Samsung. Under each extension, you'll find a series of configurable options such as thermal settings, performance settings, indexer and scalar settings, and developer options. Simulating bottlenecks in Device Simulator. Sometimes we need to be able to simulate bottlenecks in order to test out different scenarios. Simulating bottlenecks can be difficult, but with Adaptive Performance's integration with Device Simulator, we can test our various scenarios directly in our editor instead of waiting for our device to heat up in order to benchmark that scenario. With our thermal settings in Device Simulator, we can set our device to throttle or to warn us that throttling is imminent. We can also adjust our levels and trends to be positive, which means that our device is generating heat. With the performance settings, we can set our current bottlenecks to be CPU, GPU, or target frame rate. Similarly, we can set our CPU and GPU levels accordingly to simulate how frequently the CPU and GPU are performing work. Both the thermal and performance settings will affect how adaptive performance tweaks your game's performance via indexers and scalars. With Device Simulator, we can enable different scalars to see how adaptive performance accommodates when the device is throttling. For example, we can allow adaptive performance to tweak the shadow settings when we set the GPU to be our bottleneck and our warning level to be throttling with an increase in both our thermal trends and levels. In real time, we can see that our shadows are not rendering as far away now. When we reset our warning levels to no warning and decrease our thermal trends and levels, we can see that our shadows are now rendering again at the original distance. We can also override the scalar ourselves with the slider to test individual settings. For example, we can set our adaptive LOD value to 3, which will use our lowest quality LOD for our rocks and vegetation in the Botatech demo shown. Creating custom scalars. With adaptive performance, we can create custom scalars to extend how we control our game settings, including with settings that are not automatically provided. To implement a custom scalar, you must implement the Adaptive Performance Scalar class. For example, we can describe the texture quality and size per level by setting the QualitySettings.MasterTextureLimit. We override the onLevel virtual function and implement a switch statement based on the current level of the scale. Based on the current level that adaptive performance reports to us, we can set our QualitySettings.MasterTextureLimit to a higher value, which will use a lower-scaled texture mipmap of all our textures. We mark that our custom scalar impacts our visuals and specifically targets the GPU since we are dealing with texture sizes. We also describe a max level so that her game's visuals are not entirely lost, as higher-leveled mipmap textures are half the dimensions of a lower-leveled mipmap texture. When we view Device Simulator and look at our scalar extensions, we can see that our custom scalar is now registered as a configurable scalar. We can enter play mode and interact with our scalar and see how our texture quality and size readjust based on the current level. Adaptive Performance provides out-of-the-box features to allow your game to react appropriately to the current state of your device. To learn more about Adaptive Performance, you can view the samples we've provided in the Package Manager by viewing Package Manager, Adaptive Performance, Samples. Each sample interacts with a specific scalar, so you can see individually how each scalar affects your game. We also highly recommend viewing the end-user documentation to learn more about adaptive performance configurations and how you can interact directly with the API. The documentation, along with other relevant links, can be found in the description below. Thanks for watching.